Assalamu alaikum. I am Yeasin Arafat Ashik. I am going to present a complex engineering problem that is smart traffic light system and adaptive sensor based traffic signal controller. Why I chose this complex engineering problem? Because I face some problem in our daily life. Like traditional traffic light use fixed time and do not check real traffic, which affect of fixed time system, traffic jam, long waiting time, fuel wastage, driver frustration, and high emissions. And what is my performance goal? My performance goal is low cost and easy to use on city roads, works in real time, safe and still works if sensor fail, can be updated in future, AI, cloud, ambulance priority, and reduce waiting time by at least 30%. I gather some information like I take some review like read IR and ultrasonic sensor information, static Arduino and ESP32 microcontroller, research smart city project around the world, look at existing smart traffic system, and I sketch holder analysis. I talk with daily passenger, asked traffic engineers, worked with city officials, found different need and problem. And my field survey, observe traffic flow at the intersection, measure vehicle queue length, record current signal timing, note unusual traffic situation. And I also gather some solution. One is fixed time signal, efficiency low, cost also low. Preset cycle, no adaptation to traffic density, which is already existed in our country and in our system. Manual traffic control, efficiency medium, cost medium. Human officers directing traffic, health and safety risks, which is also existing in our country. But I prefer that sensor-based traffic signal, which efficiency are high and cost moderate. Real-time IR ultrasonic sensoring, cost-effective and scalable. And another is AI camera-based control, which efficiency is very high, cost also high. Computer vision with deep learning, high accuracy but expensive, which is not my topic. I select the sensor-based smart signal analysis and select a solution. Functional analysis. Sensor-based system provide real-time response to vehicle density changes at each lane. Economic analysis. Arduino or ESP32 components are low cost, almost $30 to $50. No major infrastructure change needed. Safety, reliability, battery or solar backup ensure continuous operation and watchdog logic prevent signal conflicts. Decision about the sensor-based smart traffic signal. Real-time traffic adaptation. No fixing time. Low-cost system using. I use usually Arduino and IR ultrasonic sensor. Easily to expand to more roads. Separate spark can be tested independently. And here is my block diagram of my project, where one is microcontroller and which at the corner of the road. And my system component is input sensor, IR sensor, ultrasonic, and optional camera. IR sensor, vehicle detection, ultrasonic, queue length, microcontroller, Arduino, process sensor data, run adaptive logic algorithm. Output, read red, yellow, green signals, dynamic green light duration, safe transition, sequencing. Power, primary grid electricity, then backup solar and battery. Here is the block diagram which I sketch and use ChatGPT to find it out and make also it using ChatGPT. And this is the visual image of Arduino which I collect from circuit digit. And how it's work. Detection, sensor send signal to the Arduino when a vehicle passes or stays in a lane. Processing or logic, the code calculates density. For example, if three cars are waiting in lane A but none in lane B, the Arduino priorities lane A. Action. The Arduino switches the appropriate LED edge to green for a longer duration while keeping other lanes red. Here is the prototype of my project where I use 5-volt power supply USB or solar, and I say IR sensor in every road, and also a ultrasonic sensor which is detect the QE length and the number of vehicles. And this is the diagram of Arduino circuit, and this is also a prototype image of my project, and this is the flowchart where initial sensor and lights and the read the vehicle count per lane, compare traffic density, assign green to beside lane, set timer, choose signal, and time expert, then it repeat again. If road A has 50 vehicles, then it take 16 seconds with green light. At road B, 5 vehicles, it take 20 seconds with red lights. Road C, 10 vehicles, it take 40 seconds with yellow lights. My implement timeline. Survey and data collection, it take 2 days. Design and prototype, it take 5 days. Testing and validation, it also take around 2 days. And phase 4, report and presentation, it take 1 day. Advantage, risks, and future upgrade. The advantages of my project that reduce traffic delay and waiting time, saves fuel and reduce emissions, improves road safety, real-time adaptive, no manual input, scalable for smart city integration. And my risk factors. Sensor failure. If the sensor fail back to fixed timing. Power outage. I also use as a backup solar and battery. Weather interference. Waterproof housing. I use waterproof housing because of the rain or others problem. Maintenance cost. Module replacement parts. My future upgrades. Ambulance priority system. AI traffic prediction. Cloud dashboard monitoring. Mobile app integration. Smart city network link. And I will make it for 4-line density-based logic and red light runner detection. And the final part, the conclusion of my project, that I want to build a project like the smart traffic light system represent an effective, cost-efficient, and scalable modern engineering solution by leveraging sensor technology and embedded microcontrollers. It adapts in real time to actual traffic condition, addressing a genuine complex engineering problem. Thank you. Assalamu alaikum.